Hello everyone, I am Arindam and today's topic of presentation is using Flutter and IoT based application. What is IoT? The Internet of Things refers to a network of connected devices that collects, process and exchange data over the internet. These systems improve automation and efficiency across the industry. I know you have heard about this term, the Internet of Things. It is just exchanging the data that collects the data over the internet, and it used for various purposes, for automation mainly. Now, IoT comprises of three things: microcontroller, sensors, and actuator. Microcontroller. A microcontroller is a compact integrated circuit that acts as the brain of an embedded system. It contains a processor, memory, input-output peripherals to control electronic devices. Microcontrollers are widely used in IoT for real-time processing and automation. Famous microcontrollers: Arduino Uno, used in DIY projects and prototyping; ESP8266, ESP32, Wi-Fi enabled microcontrollers for IoT application. Actually, I have built a project using ESP32 myself, so I'll show you how this works. And Raspberry Pi Zero microcontroller for automation with low power consumption. There are industry level microcontrollers also, like Raspberry Pi 4, Raspberry Pi 5. These are all very good microcontrollers. Sensors in IoT. A sensor is a device that detects and measures physical properties such as temperature, motion, or pressure and converts them into electrical signals for processing. Sensors are essential in IoT for real-time data collection and automation. So, for example, think of sensors as you want to measure the temperature of some place. What you have to do is you just installed a DHT11 sensor, that is a temperature sensor, and with a microcontroller, and send it to some cloud platform, let's say Firebase. So you'll get the data of the temperature of that area continuously in your Firebase that you can use for visualization or any requirement you have. Now let me give you some example of sensors. The gyroscope and accelerometer sensor used in drones to maintain stability, detect motion. The You can use this sensor to know about the orientation of anything. Like our phones have this sensor to give the screen orientation, to control screen orientation, and many more. Temperature sensor, DHT11 DS18B20, measures environmental temperature in smart homes and industrial systems. Ultrasonic sensor, used for obstacle detection in robots and automation systems. The ultrasonic sensor, the DHT11, all these sensors, they are quite useful. Like the ultrasonic sensor, you can use it to measure the distance between objects also. Or the gas sensor detects gas like CO2, LPG for air quality monitoring. All this data, you can store it to some Firebase, or you can use it directly with some actuator and perform some action and automate this thing. Now let's talk about actuators in IoT. So what is actuator? An actuator is a device that converts the electrical signals into physical action, such as movement or rotation. Actuators play a crucial role in IoT by enabling devices to interact with their environment. Now, actuators are, let's say, the component that work on the detected data. Like, let's talk about a sprinkler system. There is a DHT11 sensor which senses the temperature of the room. If the temperature goes beyond a certain threshold, it would tell the actuator to like to turn on the sprinklers. So this is how the whole process works. Now let me give you some examples of actuator. One is servo motor. It's mostly used in robotic arms and drones for precise movement control. Stepper motor used in CNC machines and 3D printer for accurate positioning. Solenoids used in door locks, automated valves for control mechanical actions. Uh, like there are so many uses of these things. The automatic door system, it uses the distance between you and the door and it when the distance goes beyond a certain threshold, it opens the door. Similarly, it closes the door. And some piezoelectric actuators used in ultrasonic sensors and medical devices for vibration-based functions. Now, the question is, why use Flutter for IoT? Now we know IoT have a lot of scope and a lot of use cases, but why should we use it with Flutter then? So, Flutter is a powerful cross-platform framework that excels in IoT application due to its real-time UI capabilities. Uh, we can use Flutter with IoT in a lot of spaces. For example, you can set up a anti-theft mechanism at your home that will just give you a notification or something in your app. So isn't it convenient? There are a lot of use cases. You can use WebSocket to connect your sensor data to get it in your Flutter app and use that data. So seamless. Yeah. So let's continue. Yeah, the different methods of to connect Flutter app with IoT. First method is MQTT. It's message queuing telemetry transport. It's a lightweight messaging protocol designed for low power IoT devices operating over unreliable networks. It follows a publish subscribe model where the devices communicate through an MQTT broker. The Flutter app and the IoT device connect to a MQTT broker such as Mosquito, HiveMQ, or AWS IoT. Device publish messages to specific topics, example /drone /movement, and subscriber receive updates in real time. So this protocol it's really helpful, like for transferring of data in real time. MQTT supports quality of services level, ensure reliable message delivery, ideal for IoT applications requiring low bandwidth usage and asynchronous communications. HTTP REST API for IoT communication. We have all used HTTP REST API till now. In this, there is an endpoint that we hit with a request. Similarly, in IoT too, RESTful APIs allow Flutter apps to send and receive data from IoT devices, understanding standard HTTP requests. This method is widely used for cloud-connected IoT applications. The IoT devices or backend server exposes a REST endpoints, example get slash device status. What it will do is it will get the status of the device, and similarly a post device control, you can send some control signals with it in the body of the data, the body of the request. And it will give the IoT device that controls. The Flutter app makes API requests to retrieve data or send commands. And yeah, so using the Flutter app, you can just make some requests, and responses are typically in JSON format. So you have to parse the JSON format back so that you can use in Flutter app. Suitable for applications requiring periodic updates rather than continuous streaming. Yeah. Because right, you can't make like thousand, well you can, but it's not ideal you making 1,000 requests per second. So it's not a very good uh, it's not a very good tool or a protocol for continuous streaming. Rather, it's for periodic updates. It's a very helpful. Bluetooth Low Energy for direct IoT communication. BLE enables Flutter apps to communicate directly with nearby IoT devices without needing internet access. It is commonly used in wearable devices and smart home systems. So our smartwatches, our smart glasses, everything use Bluetooth, and that connects with our phone, and you can share data over them. The Flutter app scans for available BLE devices and establish a connection. Data is exchanged through BLE services and characteristics where specific data attributes, example, battery level, sensor readings are read or written. BLE operates in different modes, including advertising and connection-based communication. It's used for short-range IoT applications requiring minimal power consumption. Yeah, Firebase as a cloud bridge for IoT. You can always use cloud for transferring data over the internet. Firebase can serve as an intermediary between IoT device and Flutter apps by providing cloud-based data storage and real-time synchronization. IoT devices push sensor data or status updates to Firebase, Firestore, or real-time database. The Flutter app listens for database updates and reflect changes instantly. Cloud Functions can process data, trigger alert, or execute commands useful for applications requiring remote device monitoring and cloud-based controls. So, like, there are endless possibilities with cloud. If you have set up, let's say, multiple GPS devices and you are sending all that data to your Firebase cloud, well, with that, you can use it to show it to through KML to your Liquid Galaxy rig also. You can monitor all those places with their exact coordinates, and you can use also some sensors with them. So, like you can use some temperature sensor, and you can monitor what's the temperature of that places over the internet, and you can visualize it too in the Liquid Galaxy rig. So yeah, Firebase is a very good tool. Now, WebSockets for real-time communication. WebSocket establish a persistent full duplex communication. Duplex, it means you can communicate in two-way. It's like in HTTP request, it's just a one-way communication. The client send the request to the server, and similarly, but in WebSocket, you can communicate in two ways. It's a duplex communication channel between a Flutter app and an IoT device or server. Unlike traditional HTTP requests, WebSocket keeps a continuous connection. So you can use it for the continuous data transfer. It's a very good tool for that, allowing bidirectional data exchange with minimal latency. The Flutter app connects to a WebSocket server using a URL, particularly ws.// all the WebSocket URL like starts with this. Messages are sent and received instantly as events without requiring repeated HTTP requests. IoT devices process incoming commands and send sensor data back in real time, commonly used for applications that require continuous data streaming, such as remote controlled drones and live monitoring systems. Now, I have created a project that will demonstrate the use of IoT with Flutter app. So this is a drone that uses a ESP32 microcontroller. I have coded it for now. It's like the microcontroller is used as a flight controller for the drone. I have used WebSocket to connect it to my Flutter app. Let's read about the components. Okay, yeah, it have a MPU 6050. You can see the middle. This sensor is a MPU 6050. It's a gyroscope accelerometer. It is used to stabilize this drone. And I have a Flutter app that controls this drone's motors by sending it the control signals via the WebSocket over real time. So yeah, its features are real-time data streaming. It's a sensor-based stabilization. It wirelessly controls through a Flutter app. Now, let me explain the workflow so you can get a good idea about how you can achieve, like how you can connect your IoT devices with your Flutter apps. So for this example, I have used a MPU 6050 sensor. This is a gyroscope accelerometer sensor that is used for the stabilization data. Like if my drone is tilted in some way, I have to know, right, that it's tilted, and I have to give that motor more power. So it's uses for the stabilization of the drone. That data, that sensor data, it goes to our flight controller, that is our ESP32 that we are currently using. Okay, one more thing, why I have used ESP32 is because ESP32 can be accessed through Wi-Fi. Like it have AP mode, which is access point mode, in which it creates its own hotspot, and that we use for the WebSocket connection. Uh, the WebSocket server, yeah, it connects with the flight controller and the motor controls. The ESP32 sends the PWM, that it's pulse width modulation signals, to our ESC controllers, and ESC controllers are then connected to our motors. That's how the motor gets the signal, how fast they have to rotate. And the WebSocket server, it is connected to a Flutter app. That is our user interface, where from like that contains the joysticks, and from the joystick we can sense the data to our ESP32 microcontroller. It used for control signal processing. It uses a WebSocket client that is connected to our WebSocket server, and yeah, okay, visual feedback. Now, let's deep dive into the microcontroller I have used and why I have used it. I have used a Room 30, ESP32 Room. I have used this specific microcontroller because it has the built-in Wi-Fi and Bluetooth. So I can create the WebSocket just by using this. I don't have to integrate a Wi-Fi module separately. So why ESP? Yeah, high power, high processing for real-time application, dual core processor for multitasking, flight controller communication, integrated Wi-Fi Bluetooth for seamless connectivity, multiple GPIOs for sensors and integration. GPIOs are the pins that we can use to connect it to some sensor or for like to some actuator that can be used for any data that you are willing to transfer or to show to have like to make something happen. Like for example, I am using GPIO 5 and 4 here with the gyroscope sensor, and I am using these 4 pins for the ESC controllers that will send my PWM signals to my motor. So what is MPU6050? It's a sensor for drone stabilization. As I've already mentioned, it's a 6-axis motion tracking sensor. It has gyroscope plus accelerometer. Why MPU6050 for drones? It detects tilts and angular velocity for stabilization, helps maintain the balance of the drone in real time. MPU6050 connections with ESP32. So yeah, I can show you this. So currently, it have two SCL and SDA pins, and these SCL and SDA pins are connected to 22 and 11, 21 similarly in my ESP32. And I have also connected the VCC, that is the voltage pin, and the ground pin to my voltage and ground pin of the ESP32, as you can see in the diagram too. Connecting ESP32 with ESC and BLDC. So right, the ESP32 is then connected to the ESC controllers. These ESC controllers are mostly used to give the accurate power to the motor so that it rotates in a specified power that it should. Yeah. So let's see. ESC, a device that regulates power to the BLDC motor, converts PWM, that is pulse width modulation signals, from ESP32 to varying motor speeds. BLDC motor, it's a brushless DC motor used for drone propulsion, requires precise speed control for stabilization and movement. Connection overview, ESP32 generates pulse width modulation signals to control motor speed. ESC interprets PWM signals and adjusts motor power accordingly. BLDC motor receives power from ESC and spins at the desired speed. And yeah, I use pulse width modulation. It provides precise speed control for BLDC motor, ensures smooth throttle transition, and enables stable flight adjustment based on sensor feedback. So now let me show you the app that I'm currently using to control the drone. This is the app that I have created using the Flutter. For this, I have used the joystick package to create these joysticks and the WebSocket channel. Let me show you. You just have to add this WebSocket channel in your Flutter pubspec.yaml file and run the flutter pub-get command. Just run the flutter pub-get and it will install the dependencies, or you can just click the get packages. Now after this, you can see a connect button here. So what's the purpose of this connect button is, firstly, like the microcontroller ESP32 enables its AP mode and starts a WebSocket server. This connect button is then used to connect to the WebSocket server. Let me show you the this is Arduino IDE where we code the ESP32 and program it. So yeah, this is the code that enables the WebSocket server. Here we have used some packages, ESP async web server to create the web server, and async TCP for the transmission. And these are all the packages that uses for the WebSocket and WebSocket configurations. So I have initialized my SSID and password with the SSID password that will be used to connect to the network. Then I have started at a port 80 the server, and I have added the /ws that is used for the WebSocket endpoint. Then I am using three variables here: throttle, right joystick, and right joystick X and right joystick Y. Why I am using this is throttle is the value that how fast I want my all motors to go. And this is used to control the orientation of the motors, like orientation of the drone, the tilt of the drone and all. Then I have created a WebSocket event that will, what it will do is it will look for three values: the throttle value, the right joystick X value, and the right joystick Y value. And it will take these values from the WebSocket connection, and it will use these values to give it to the motor so that our drone can fly properly. So yeah, then just I have initialized serial.begin. This is a setup code. I have used the baud rate of this, and after that I have just initialized it the ESP32 in AP mode. What it will do is it will create a hotspot that I will use to connect it to my phone, and that will create the WebSocket. Then I have just set up the WebSocket. I have used the event that I just created so that we can get the throttle and right joysticks values. And in the end, I have just add a handler for the WebSocket, and I then started the server. The server will be started mostly at this endpoint, right? Yeah. So this is how I am managing the, like how I am transferring the throttle values and the data with the help of WebSocket. Now let's come to our Flutter app and see what we are doing to connect this to the server. So in the Flutter app, I have imported the WebSocket channel package and the joystick. The joystick is just for the UI. It's not doing anything else. And the joystick values, I am listening to the joystick values. I have added a listener that stores the values like the X and Y coordinates and transfer it to the drone controller, like the flight controller ESP32 via the WebSocket. So for this, I have used the connect to WebSocket. When I click on the connect button, what it will do is it will look for these channels, the endpoint that our ESP32 has started, these endpoint, and it will create a connection, a WebSocket connection between that server and this app. And because it's a duplex channel, our ESP32 can also send us messages of like success, or in my case, it can be used for the battery percentage, I'll say. Yeah, so once this is done, you can just initialize it. Like you can just connect it. Once it's connected, you can send the joystick data the over the web socket. just by using channel.sync add JSON encode, because of course you have to encode it into JSON format. And here we are decoding it. Yeah, here we are decoding this JSON data and we are expecting a JSON data. So yeah, this is how my drone is working. Let's continue with our PPT. Okay, so yeah, this is the UI of our app, Flutter app, and this is a demonstration video of the drone. So let's just quickly watch it. Yeah, as you can see, all the 4 motors are working perfectly in sync. This is all happening because of the WebSocket and the data. It's the data transferring through the WebSocket. So now you will be wondering, can we use these IoT devices? Can we use IoT devices and make something in our Liquid Galaxy rig? So yeah, I have some ideas about how we can use this. We can we can use a pressure sensor and find out the altitude of some position. We can use a GPS. This is a GPS sensor. It's a Neo 6M GPS. It doesn't require any internet connection. It just when you first connect it, it have to connect to the satellites, and once it's connected, you can get the real-time location, the longitude, latitude, wherever you are. Like, but it's really hard to connect to the satellite. I have to wait for 2 hours on my terrace for it to connect to the satellite. So yeah, it's very difficult. But once you do connect it to the satellite, yeah, it's a very handy tool. So you can use these satellites values and create KML through it. Like you can use for that, you can use Firestore, where you can store these location with some sensor data. For example, temperature sensor, humidity sensor, and visualize it on our Liquid Galaxy rig. Like it will be a pretty good project. Or you can use the our gyroscopic sensor and create let's say create some goggles that can control the orientation of the Liquid Galaxy rig just by movement. So yeah, these are some pretty good projects that we can make through our IoT, like just by connecting IoT and Liquid Galaxy rig. And by we can also make some very good projects by connecting it to our Flutter app. So it's all on us. So yeah, this was it. Let's see if I have missed something. No, that was it. And thank you for watching. I hope you liked this video. Thank you.